Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 6, 6.2, and we're looking at volumes of revolution. A volume of revolution is the volume of the solid created when a section of a curve is rotated by 2 pi radians, 360 degrees, around the x-axis. Now, it can be around the y-axis, but in this lesson, we'll just be looking at rotations around the x-axis. So you have a curve, y equals some function of x. We just want a section of that curve, so there'll be limits a and b, and then we'll just want the curve between those two limits. And then we're going to rotate that by 360 degrees, one complete turn, all the way around the x-axis. And you get a solid that looks a little bit like that. Putting in the two limits, so a is the lower x value, b is the higher x value, and that is how you'd find the volume of that solid. Surprisingly straightforward. You do the integral between a and b of pi times by y squared. So whatever y is as a function of x, you'll have to square it. And just carry out that integration in the normal way. So for example, if you had to find the volume of the solid generated when y equals x squared plus 1 is rotated about the x-axis through 360 degrees, between the limits x equals 0 and x equals 3, the volume will equal, using the formula, the integration between 0 and 3 of pi, and then y is x squared plus 1, so y squared is x squared plus 1 all squared. Pi is just a constant, always with a constant. If you're multiplying by it, you can just take it outside of the integration, and you'll notice in the textbook they frequently do that straight away. You can do whatever point you want to. Okay, I'll let you have a go at finishing this question. So you need to multiply out those brackets, carry out a normal integration, put in the limits. Pause the video, have a go, come back to me when you're ready. Okay, let's have a look. So squaring those brackets gives us x to the 4 plus 2x squared plus 1. And I have chosen to take the pi outside of the integral and times by it afterwards. Integrating that will give me a fifth x to the 5 plus 2/3 x cubed plus x. Then I need to put in the two limits, 0 and 3. That will give me that when I put in 3. Putting in 0 does just give me 0. And tidying up that first bracket gives me 348 pi divided by 5 for the volume of the solid. Now, if we need to use parametric equations, then the formula for using parametric equations is that it is fairly similar to the other equation. We've still got pi, we've got g of t squared, but g of t is the function of t for y. So just as we had y squared with the other formula, we now have g of t squared. And as before, when we were doing a parametric integration, we don't just have f of t, the function for x, we actually have to differentiate that. So we'll have f dashed of t, differential of f of t. Let's have a look at how this works out in practice. Find the volume generated when the curve represented by the parametric equations, x equals 3 over 2 and y equals a half, is rotated about the x-axis through 2 pi radians from t equals 1 to t equals 3. So the volume, using the formula and taking the pi outside straight away, will be that g of t is the function for y, which is t to the half. So g of t squared is t to the half squared. And then f dashed of t is the differential of f of t, which is the differential of t to the power of 3 over 2, which is 3 over 2 times t to the half. Okay, I'll let you carry on from there. So we'll need to multiply these out, collect everything together, integrate it, put in the limits, and get the answer. Have a go at doing all of that. Pause the video. Come back to me when you're ready. Okay, let's have a look. So when I square this bracket, I'll get t to the power of 1. Timesing that by t to the half gives me t to the 3 over 2. That's what I need to integrate. Integrating that will give me 3/5 t to the power of 5 over 2. Then I need to put in the limits, t equals 1 and t equals 3. And that will give me that. Popping all that in the calculator gives me that, which to 3 significant figure accuracy would be 27.5. Okay, example 3 has a couple of parts. We'll do each part one at a time. The curve represented by x equals 3t minus 1 and y equals t squared plus t minus 2 intersects the x-axis at p and q. And the first thing we're asked to do is find the values of t at p and q. Now it intersects the x-axis where y equals 0. So that is what we'll be solving for the parametric equation in y. I'll let you have a go at making sense of that. Pause the video, come back to me when you're ready. Okay, let's have a look. So as we said, the curve intersects the x-axis where y equals 0. And if y equals 0, that means t squared plus t minus 2 must equal 0. That does factorize into t plus 2 times t minus 1. And that gives us two possible values of t equals minus 2 or t equals 1. That's what we've done so far. And then part 2 asks us to find the exact volume generated when this curve is rotated about the x-axis through 360 degrees between the points P and Q. Those are the points P and Q, so those are the values we'll be using for the limits when we do the integration. Okay, this time I'll let you have a go at doing the whole thing yourself. So substitute everything into the formula up here, remembering to take care over which function is f of t and which is g of t. So have a go, pause the video, come back to me when you're ready. Okay, let's have a look. So g of t is t squared plus t minus 2. That we have to square. Then we've got to times by the differential of f of t. Well, differentiating 3t minus 1 just gives us 3, so we're timesing by 3. And then the 3 and the pi have both been taken outside the integration. So that's what we need to integrate when we square this bracket. Integrating that will give us all of this. And then we need to put in the limits, t equals 1 and t equals minus 2. That will give us that. And that simplifies to that, which simplifies to 243 over 10 times by pi. Now notice in the question, they've said find the exact volume. That means they don't want the answer as a rounded decimal. If the answer involves pi, then you would include pi. If it included something like a log, you'd include the log. But whenever they say the exact value is wanted, they mean they want something like this. They don't want a rounded decimal. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 71 and have a go at exercise 6b. Thank you very much for listening and cheerio.